So in this video, I want to go through some more examples of error propagation. For an exact value, lowercase x, x equals 14.1, so capital X equals 14.1 rounded to one decimal place. And for an exact value, lowercase y, capital Y is 2.7 chopped to one decimal place. So careful on that. Find each of these to as many significant figures as possible. So first of all, let's find the range of values for x. So the lowest value of x, because it's been rounded to one decimal place, would be 14.05, and the largest value, inclusive, and the largest value would be 14.15, not inclusive. So that's been rounded, whereas y has been chopped. So 2.7 chopped to one decimal place, so the lowest value it could be would be 2.7. The largest value, inclusive, the largest value would be 2.8, not inclusive. Okay, so these are the values that we're working with. So for number one, we're looking for x plus y. So x plus y, well, the lowest value that it could be would be the sum of the two lowest values that we've got there. So 14.05 plus 2.7, so 16.75 inclusive. And then the largest value would be the sum of the two largest values, 14.15 plus 2.8, and that's 16.95. And that's not inclusive. So find each of these to as many significant figures as possible. Well, that means that x plus y would be equal to, well, to two significant figures, we'd have 17 and 17. And that's really the best that we can do. To one decimal place or to three significant figures, this would be 16.8 and 17.0. So they both round to 17 to two significant figures, so that's the best we can do. Okay, so that's number one. Okay, right, we'll leave those on the board, so we're going to use those. So number two is x take away y. So for x take away y, if we want the smallest possible value it could be, we want the smallest possible value of x and the largest possible value of y. So that would be 14.05 take away the largest value of y, which is 2.8. And that's 11.25. Now, because we're using 2.8 there and we can't actually reach 2.8, we're going to have a curved bracket around that one. And the largest value would be the largest value of x take away the smallest value of y. So 14.15 take away 2.7. And so that's 11.45. And because we're using 14.15, we can't reach that value. Okay. So, what's the best we can do here? Well, to three significant figures, we've got 11.3, 11.5, so that's no good. Two significant figures will have 11 and 11. So, 11 to two significant figures is the best we can do for number two. Okay, now x times y, the smallest value of that will come from multiplying the two smallest values of x and y together, of course. So 14.05 times 2.7, and that's 37.935. And because we're using two values that we're including here, we can include that one. Then the largest value will come from multiplying together the two largest values, 14.15 and 2.8, and that gets us 39.62. And that's not inclusive. So, find each of the values to as many significant figures as possible. Now for this one, if it was to two significant figures, we'd have 38 and 40. So that's no good. So the best we can do here is to one significant figure, and that'll be 40 and 40. So xy equals 40 to one significant figure. Okay, now, as I said, that's the best we can do. Okay, right, number 4, y divided by x. So the smallest that this could be is if we have the smallest value of y divided by the largest value of x. Sorry, not an equal sign. There we go. So 2.7, and we're going to divide that by 14.15. And that gets us 0.1908127,208. And because we're dividing by a value we can't reach, that's a curved bracket. And the largest value will come from y being as large as possible, so 2.8, and dividing it by as small a number as possible, so 14.05. And that gets us 0.1992882,562. Just about get on the board. Okay, and because we're using 2.8 there, we're using a curved bracket. So, what's the best we can do here? Well, to 2 decimal places, or to 2 significant figures, this would be 0.19 and 0.20. So the best we can actually do is to 1 significant figure, which would be 0.2. Okay. Right. So the last one, we have x plus y over x take away y. Now, the problem with this one is that it's not straightforward to know which ones to choose in order to make the smallest and largest values. Because we've got x and y's in the numerator and denominator. What you must remember, however, is that when you are substituting values of x and y into this, you must be consistent. You can't substitute in different values for x. So you can't have the largest one on the top, largest value of x there, smallest value of x there. You can't do that. You can't mix and match. Okay? But we're going to have to go through, I think, all 4 iterations to see which one works. So if we start off with 14.05, so smallest value of x and smallest value of y, so plus 2.7 over 14.05 take away 2.7. And then if we try 14.05 plus the largest value of y, 2.8, over 14.05 take away 2.8. Okay, we work out both of those. We're also going to need to work out 14.15 plus 2.7 over 14.15 take away 2.7, and 14.15 plus 2.8 over 14.15 take away 2.8. Okay, so let's see them. So we've got 14.05 plus 2.7 over 14.05 take away 2.7. So this is 1.475770925 full calculated display. This one, let's change the 2.7s to 2.8s. We get 1.497777778. So I'm assuming that's 7 recurring. And it's just the calculator's rounded the last figure. This one, so we're going to change the 14.05 to 14.15 and the 2.8s back to 2.7. And we get, oh no, I missed out a decimal point. There we go. Right. 1.471615721. And if we change the 2.7s to 2.8s, we get 1.4 9339207. Okay, so the smallest value of those is this one here. So using the largest value of x and the smallest value of y. So 1.47161571, curved bracket. And the largest value is this one here. So 1.49777778, curved bracket. And that's using the smallest value of x and the largest value of y. So we can write this to be equal to, now to three significant figures, this would be 1.47 and 1.50, so that's no good. 2 sig fig, that's 1.5, and that's 1.5. So 1.5 to 2 sig fig is the best we can do for that one.